This is muscle video number 12, and this is the third and final installment of the action potential series. And so what we want to do is we want to wrap up some of the learning objectives that we kind of touched on earlier in the previous video. Where is the action potential generated, and what does it mean for the action potential to be propagated? The second one is looking at the difference between the action potential at the motor end plate and everywhere else on the skeletal muscle fiber. So let's go ahead and revisit our action potential slide. When we look at the action potential, to rehash, remember these are the numbers that you must know, and I gave that to you on this particular slide. These are the numbers that you must know. And you really should be able to draw this out and be able to talk it through. So again, at point A, we see chemically gated sodium doors open, therefore sodium goes from out to in. At point B, voltage gated sodium doors open, and I'm also triggering the opening for voltage gated potassium doors. Sodium rushes in like crazy. At point C, at this point, both of the chemical and voltage gated sodium doors have closed. At point C, the voltage gated potassium doors, which had initially started opening here, but didn't open enough for potassium to get out, at this point, at point C, they're fully opened. Potassium now exits the cell, goes from in to out, and I start repolarizing the cell, and I come back to resting membrane potential. Okay, so if you look at that, if I were to now look at these two sections, section A to B versus section B to C, and if we were to say to describe those, you would say depolarization. So A to B is depolarization, B to C is depolarization, C to D is repolarization. So now let's look at the two sections, this part versus this part. If I say to you, which one is slow depolarization and which one is fast depolarization, then you ought to say, well, slow depolarization is this section, A to B, where sodium trickles in as a result of opening up of chemically gated sodium channels. Section B to C then is fast depolarization, where I've opened up tons of voltage-gated sodium doors where sodium now floods in. So I'm trickling in, flooding in. One more time, I'm trickling in right over here and then flooding in. All right, so that is the action potential. Now, again, where is all this stuff happening? All of the stuff is happening right over here at the motor end plate. So if I were to take that image, that image of the action potential, that is where this thing is happening right over there at the motor end plate. All right, so that's what we see. So now what ends up happening is that if you go back to one of the earlier videos, I said that signal spreads like a wave. So what we actually end up seeing is that this guy comes up and then he comes right back down. And when he comes right back down, immediately next door, I have a whole bunch of not chemically. In fact, I don't have any chemically gated channels. Now I have, I have a whole bunch of voltage gated channels. And once the membrane potential here at my motor end plate is basically flatlining, this guy over here is like, whoa, let me take that back. I want to say it differently. Not so much flatlining, but once my membrane potential here at my motor end plate hits negative 55, then a whole bunch of voltage gated doors here look next door and say, whoa, our neighborhood has changed. We're at negative 55. So now voltage gated doors slam open and I spike up very, very rapidly. Then what ends up happening is that as I'm doing that, once I hit negative 55 right around here, a whole bunch of voltage gated doors in this neighborhood look next door and they say, whoa, I have spiked up. And so now I'm going to start opening up. And that's what we see. Then a whole bunch of doors right over here in that location do the same thing. So what we're seeing then, and really what you should see is something that looks more like this. If I could try to make this travel visually, what you'll see is this is what you end up seeing. That action potential travels from point B all the way down to this last point C. That's what we're seeing. Now, again, this is the action potential. Oops, this is the action potential at the motor end plate. Now, if you look at this one, let me ask you the question. Action potential everywhere else besides the motor end plate. What's the main difference? What do I mean by everywhere else besides the motor end plate? I mean here. Darn it, that's not what I meant. I meant this little guy right over here, and then right over here, and right over here, and right over here, and right over here, and right over here. This is everywhere else besides the motor end plate because, again, this is the motor end plate. So if you look at that, what's the difference? And the difference is, well, you don't see a slow wave of depolarization. Instead, you see rapid depolarization only. Why is that? Because I don't have any chemically gated doors at this point. Remember that Acetylcholine only binds right over here to the motor end plate. And in fact, I don't even have chemically gated channels. I don't have any chemically gated channels right over here. These are all voltage gated channels. So since they're all voltage gated channels, the action potential is going to look a little different, and it's going to look like this. So what's the difference? The difference is I don't see a slow wave of depolarization. It's just rapid depolarization the whole way through. If you contrast those two, it's just this part. See that section? Slow depolarization and then rapid depolarization, rapid repolarization. Here, I'm at nothing, and then I just see rapid depolarization and then rapid repolarization. So that's the difference. So maybe this slide will help. If you look at this picture, what we're seeing here then is my motor end plate will be somewhere way over here, and at this point what I'm seeing is a whole bunch of voltage gated doors. So this event happens right over there, and then after that comes back down. So after this comes back down, at that point what we're seeing is this event then is happening right over here. Same thing. So again, these guys are looking next door, and once I hit negative 55, wherever threshold was, negative 55, these voltage gated doors are saying, whoa, look at our neighborhood. It's changed from negative 70 to negative 55, so now that's our signal. So they open up. So then next thing happens is the next set of ion channels, there aren't here in this picture, but just imagine there are, they'll do the same thing. So again, ultimately what you're seeing, in the big picture, what you're going to end up seeing is you're going to see that action potential itself travels, essentially goes from here all the way through, just like that wave in the stadiums that I had shown you in the previous video. Okay, so now let's kind of put a bow on this thing. Here we are again. This was the very first slide that I showed you guys before when we started off this whole thing on muscle tissue. The electrical event. We're now done talking about the electrical event. So a neuron sends its signal to the muscle. Again, how that happens, who cares for now? That's part of the nervous system. Neurotransmitters are released at the motor end plate, and then from there, chemically gated sodium doors open, and that allows ultimately sodium and potassium to cross the membrane and that action potential. From there, step B happens over again. So that would be this thing over here. This guy here happens over and over again at this point, and at this point, and at this point, and at this point, and at this point, until it looks like a wave coming all the way down to the sarcoplasmic reticulum. Now I do say here depth of the muscle because you need to keep in mind that all of this stuff is occurring at the cell membrane. And so all of this electrical signal is happening. These are membrane potentials. So if you were to go deep, deep, deep inside here, you may not even feel any kind of electrical current or change. All of this stuff is occurring across the membrane. And so as that continues to happen, we now go and we hit the sarcoplasmic reticulum, which is that purple bag. And that purple bag of that sarcoplasmic reticulum is full of calcium ions. Calcium ion is released, and that is where this whole section, the contractile event, occurs. So the next series of videos then is really going to entertain these things. Entertain? That's not the right word. It's really going to talk about these things. So we've covered the electrical events through the first series of videos, and the next part then is the contractile event. In the big picture, keep in mind the electrical event precedes, it comes before the contractile event. You must have this electrical in order to have this. The contractile event, again, you already have some big picture. That's when your biceps contracts, right? That's when you flex your elbow. This is all the stuff that makes your elbow actually bend during elbow flexion or whatever muscle you want to talk about. And this is all the current electrical stuff that needs to happen, okay? So that'll close out this section, and the next section will go into all of this.